The lengths of fish of a certain type have a normal distribution with mean 38. It is found that 5% of the fish are longer than 50 centimeters. Find the standard deviation. Okay, let's start. It's probability that the length is longer than 50 centimeters is 5%, so 0.05. We will standardize this, replace x with c, greater than 50 minus mean, which is 38, divided by the standard deviation, which is sigma, equals to 0.05. This becomes 12 upon sigma is equals to 0.05. Now, since this is greater than, we'll have to fix it, and we'll instead write 1 minus probability z is less than 12 over sigma, which is also written as 5. 12 over sigma equals to 0.05. Okay, this becomes 0.95 equals to 5, 12 upon sigma. Now we'll have to find the z-score corresponding to this probability of 0.45, sorry, 0.95. Okay, that can be easily found here. At the bottom of the table, we have particular z-scores for a few probabilities given here. So when probability is 0.95, the z-score is 1.645. So z-score is 1.645 equals to, this is the z-score here, 12 upon sigma, which gives us sigma equals 7.2948, rounds to 7.29. Okay. Part 2. When the fish are chosen for sale, those shorter than 30 centimeter are rejected. Find the proportion of the fish that are rejected. Okay, so probability x is less than 30 centimeters, probability x is less than 30 minus mean, which is 38, divided by standard deviation, which was 7.2948, which gives us probability x is less than negative 1.0966. Okay, z-score is needed till 3 decimal places only, so 1.097. Okay, now again, since this is a negative number, we'll have to apply a fix first, which is the same as earlier, 1 minus 5, 1.097. Okay, let's read the probability corresponding to z-score of 1.097. So 1.0 is here, 9 is here, so this is the probability, and then 7 is here. So we'll have to add a 1.6 in the end. So we have 0.8621 plus 0.0016, which gives us 0.8637. So 1 minus 0.8637, which gives us 0.1363, rounds to 0.136 in 3 significant figures. Part 3. 9 fish are chosen at random. Find the probability that at least one of them is longer than 50 centimeters. Okay, so this is binomial distribution now. We have to find the probability that at least one of them is longer than 50. So 1 could be longer, 2 could be longer, 3 could be longer, 4, 5, 6, 7, 8, and 9. All 9 could be longer than 50 centimeters. So what we'll do, instead of finding the probability 1, 2, 3, 4, 5, and so on, we can do 1 minus probability x is equals to 0, which means 1 minus probability 0 fish is longer than 50 centimeters. So that will be 9C0. Probability of success is that the fish is longer than 50 centimeters, which is this 0.05. So 0.05 power 0, and 1 minus 0.05, which is failure, power 9. So this gives 0.3697, which gives 0.370 in three significant figures. A survey of adults in a certain large town found that 76% of people wore a watch on their left wrist, 15% wore a watch on their right wrist, and 9% did not wear a watch. Part 1. A random sample of 14 adults was taken. Find the probability that more than two adults did not wear a watch. So, this is a question on normal distribution. They're asking find the probability that more than two adults did not wear a watch. So maybe three adults did not wear a watch, or four adults did not wear a watch, or four, five, six, seven, 8, 9, 10, 11, 12, 13, 14 adults did not wear a watch. Instead of finding all these probabilities and adding them, it's better to do 1 minus probability no adult did not wear a watch, or just one adult did not wear a watch, or two adults did not wear a watch. So 1 minus total number is 17. This one will be 17C0. Probability of success is probability of not wearing a watch, which is 9%. So 0.09 power 0. Then 1 minus 0.09 would have power 14 minus 0, which is 14. Then minus 14C1, 0.09 power 1, 1 minus 0.09 power 13, and then minus 14C2, 0.09 power 2, 1 minus 0.09 power 14 minus 2, which is 12. This would give 0.1255, which rounds to 0.126. Part 2. A random sample of 200 adults was taken. Use a suitable approximation. Find the probability that more than 155 wore a watch on their left hand. Okay, using a suitable approximation means we have to change binomial into normal distribution. For that, the first thing we do is apply continuity correction. Find the probability that more than 155 wore watch on their left wrist. So apply continuity correction greater than 155 means 155.5. We're taking the upper bound. And just a quick reminder, if this was greater than or equals to, then we would have taken the lower bound. And if it were just less than, then again we would have taken the lower bound, which would have been 154.5. But if it were less than or equals to, then we would have taken the upper bound. Okay, so now we will be applying standardization, which is subtract the mean, and divide the standard deviation. Now, how do we find the mean and standard deviation? Mean in binomial is n times p. N is 200 adults, and p is probability of wearing the watch on left wrist, which is 0.76. This gives us 152, and standard deviation is square root of npq, or np1 minus p, which is 200 into 0.76 into 1 minus 0.76, which gives 6.03986. Now we apply standardization by subtracting the mean 152, dividing with the standard deviation, which is 6.03986, which gives us 0.57948. So we will use only 3 dp for z-score, so 0.579. Okay, since this is greater than, we'll have to apply a fix and write 1 minus 5, 0.579. Find the probability corresponding to a z-score of 0.579. 0.5 is here, 7 is here, so this is the probability. And in the end, we have 9, so we add 3, 1 to the last two digits. So 0.7159. Okay, so 0.7157 plus 0.0031. This gives us 0.7188. Subtract that from 1. So 1 minus 0.7188, which is equals to 0.2812, and in three significant figures is 0.281. Give an example of a variable in real life which could be modeled by normal distribution. So you could say height of students in a class. That is just one example. There's literally a gazillion. Height of students in class, or lengths of leaf on a tree. That would work as well. Almost everything in nature follows a normal distribution. Okay, part 2. The random variable x is normally distributed with mean mu and variance 21.0. Given that x is greater than 10.0 is equals to probability that x is greater than 10.0 is equals to 0.7389. Find the value of mu. Okay, replace x with c. Greater than, standardize this by subtracting the mean and dividing with standard deviation. Standard deviation is the square root of variance. And this is equals to 0.7389. Okay, now since this is greater than sign, and we have a probability greater than 0.7389, that means that this z-score is a negative value. How do I know that? Let me show that to you graphically. Here's a normal distribution curve. Here's 0, and z greater than 0 has a probability of 50%. If probability that z is greater than 0 is 50% or 0.5. But this is greater than 0.5, it's 0.7389. So that means that z value might be somewhere over here. And this probability is 0.7389. So the z-score is negative. So this value, 10 minus mu upon square root of 21, is a negative value. So I'm going to replace this with negative k. Probability z is greater than negative k is equals to 0.7389. Now this is the same as probability z is less than k, or phi k. So phi k equals 0.7389. Now we're going to find the z-score that gives us this probability 0.389. Sorry, 0.7389. Okay, 0.7389 is right here, which has a z-score of 0.64. So k is equals to 0.64. Which means 10 minus mu upon square root of 21 is equals to minus 0.64. Okay. Find mu from here. It will come out to be 12.9328, which is 12.9 in three significant figures. Part 3. If 300 observations are taken at random from the distribution in part 2, estimate how many would be greater than 22. So in this case, what we'll do, we'll find the probability and multiply it with n, which is 300. So we'll do 300 times the probability we get. How will we find the probability? How many of these would be greater than 22? So probability x is greater than 22. Probability z is greater than 22 minus mean, which is 12.9, divided by the standard deviation, which was under root 21. It's better to take a longer answer, so I'm going to write 12.9328. Okay. This gives probability z is greater than 1.986 in three decimal places. Remember, we need this z-score to go till three decimal places only. Okay, now this can be rewritten as 1 minus probability z is less than 1.986. So 1 minus, read the probability corresponding to a z-score of 1.9856 from the table, and you will get 0.9765, which gives us 0.0235. Now we will multiply n with p. So 200 is equals, sorry, 300 into 0.0235, which gives us 0.05, so it'll be 7. So 7 of these will have, would be, 7 of these would be greater than 22.0. A manufacturer makes two sizes of elastic bands, larger and smaller. 40% of the bands produce larger bands and 60% are small bands. Assuming that each pack of these elastic bands contains a random selection, calculate the probability that in a pack containing 20 bands, there are equal number of large bands and small bands. Okay, this is binomial distribution. So there are total 20 bands, 10 have to be small, and the remaining 10 have to be large. So we can write 20 C10. So out of 20, 10 are, you could take small here or large here. If I'm taking this one, large, so I'm writing large probability first, 0.4 power 10. So out of 20, 10 are large, and then remaining 10 would be small. So probability of small times power 10. Okay. This gives us 0.117141, which gives 0.117 in three significant figures. Part 2. More than 17 bands, small bands. Okay, so small bands need to be greater than 17. That means there could be 18 small bands or 19 small bands, or all 20 of them are small bands. So we'll start with 20 C18. Probability of small band is 0.6 power 18. Probability of large band is 0.4 power 2 from 20 minus 18. Plus 20 C19, 0.6 power 19, 0.4 power 1. Plus 20 C20, 0.6 power 20, and 0.4 power 0. This would give us 0.00361147 rounded to three significant figures, 0.00361. Part 3. Use a suitable approximation to find the probability that the number of small bands in the office pack is between 88 and 97 inclusive, which means we have to find the probability that between 88 included, and 97. Okay, since we have to use approximation, that means we're changing binomial distribution into normal distribution. For that, the first thing we do is apply continuity correction. Okay. How do we apply continuity correction here? It says x is greater than and equals to 88. So although it says greater than, but since there's an equals to sign with it, you don't take greater than, you actually take less than, and we're going to take lower bound of 88. So we write 87.5 less than and equals to x, and then this side is x is less than and equals to 97. Only less than would have been lower bound, which would have been 96.5. But since it says less than and equals to, you take the upper bound, which is 97.5. Okay. Now we're going to standardize by subtracting the mean and dividing the standard deviation. Okay. What is the mean? Mean is equals to n times p. N is 150 and p is the probability of success, which is small bands probability, which is 0.6. That gives us 90. And then sigma is equals to square root of npq, which is 150 into 0.6 into 0.4, which gives 36. Under root 36 is 6, so standard deviation is 6. So minus 90 upon 6 less than and equals to change x to z, and 97.5 minus 90 upon 6, which gives us probability. Lower value becomes minus 0.417 in three decimal places, because z-score needs to go till three decimal places only. And on the other side, we'll get 1.25 exactly. Okay. Now, when we get a case like this, where one side is negative and the other side is positive, the rule is you add these two probabilities and subtract it with 1. So we write 5. Find the probability corresponding to the z-score of 0.417 plus probability corresponding to the z-score of 1.25, then subtract 1 from it. Okay. Now you can read this from the table and you will get 0.6616 plus 0.8944 minus 1, that gives us 0.556. The random variable x is normally distributed. The mean is twice the standard deviation. It is given that x is greater than 5.2 is equals to 0.9. Find the value of standard deviation. So we'll start by standardization. X becomes z greater than 5.2 minus mean. Mean is twice of standard deviation divided by standard deviation, and this is equals to 0.9. Okay, This shows that the z-score is negative. How do I know z-score is negative? Because we have 0 in the middle and probability z is greater than 0 is 50% or 0.5. So here if it's saying probability z is greater than something which is 0.9, that means this part of the curve will also get shaded and this z-score is negative. So 5.2 minus 2 sigma upon sigma is some negative value. So I'm going to write probability z is greater than minus k is equals to 0.9. Now this can be rewritten as probability z is less than k is equals to 0.9. Find the value of z-score, which gives the probability of 0.9. Can be found directly from here, which is 1.282. Z-score of 1.282 is equals to, gives the probability of 0.9. So k is equals to 1.282, which means 5.2 minus 2 sigma upon sigma is equals to minus 1.282. You can rearrange, find the value of sigma here. I'm just writing the answer. It'll come out to be 7.2, sorry, 7.24233 rounds to 7.24. Okay, so standard deviation has been found. Part B. A normal distribution with mean and standard deviation, with mean mu and standard deviation sigma, sorry, a normal distribution has mean mu and standard deviation sigma. If 800 observers are taken from the distribution, how many would you expect to be between m minus sigma and m plus sigma? Okay, so that means that we have to write m minus sigma on one side, m plus sigma on one side. Okay, now we will standardize this again. For that, we subtract mu and divide with standard deviation. Subtract mu, divide with standard deviation, which gives us 1, sorry, negative 1 and 1. Okay, this means we'll have to find probability z is less than 1 plus probability z is less than 1 and minus 1, which is 2 times phi 1 minus 1. Why did I do that? Because we know the rule. If we have minus some value here a and some value, positive value here, it is equals to phi b plus phi a minus 1. So in this case, since these two are identical, we're going to double it. And we have to find the probability corresponding to a z-score of 1. That will be when z-score is 1, probability is 0.8413. So 2 times 0.8413 minus 1 gives us 0.6826. Okay, and we have to find if if 800 observations are taken from this distribution, how many would you expect to be between this? Okay, so the expected value is always equals to n times p. N is 800 and p is what we just found, 0.6826, which gives us 546.08. So we write the answer as a whole number, 546.